Okay, I'm going to start the broadcast now. Okay.
The broadcast is now starting. All attendees are in listen-only mode.
Welcome to the DBA Fundamentals virtual chapter meeting for June. Today's presentation is entitled 2016 Enhancements that will make your SQL Server roar. It will be presented by Ajay Jaganan. I will be turning things over to Ajay in a minute, but I want to make a few announcements first. Okay, let me get there we go. PASS Summit, of course, is coming up in October. If you want to save money on your registration, be sure and use our discount code VC15GBQ6. And there's a deadline date coming up of July 17th to where the price goes up to full price. And if you're going to do it, if you're going to go, I would suggest going before then. You can get in for as little as $16.45 up to that point with our $150 discount code. After that, over $2,000. And in addition, if you use our code, you'll be put into a pool of people where one person will have a chance to win a $400 Amazon gift card that can kind of go along with your it's just sort of a value add, and we may actually add a few more funds to that, but we know that it'll at least be $400. So remember that date, July the 17th, and if you want to kind of save this, you can click on the little camera icon at the top of your screen and it'll put a copy to your desktop. PASS has lots of virtual chapters, and if you're here you probably already know that, but there's new ones opening up all the time with different languages and different topics. So be sure and go out there and sign up and look at other ones. Here's our virtual chapter meetings coming up. Today's, of course, and then next month, Azure SQL Database for the Production DBA with Tim Radney from SQL Skills. That'll be in our Australian Down Under chapter. Kendra Little will be doing 3 skills every junior DBA must know. I love listening to her, and she's very good at teaching beginning topics and as well as advanced, but she's very good at all of them. Of course, I put in the deadline again to save dollars on July the 17th. On July the 19th, we'll be having another presentation from the Microsoft SQL Server Tiger team with SQL Server Performance Monitoring and Baselining. August the 2nd, we'll have High Availability and Disaster Recovery 101 with Glenn Berry, also from SQL Skills. He's always fantastic. All of the presenters from SQL Skills are fantastic. Then we'll have a relatively new speaker in September, managing very large databases. And it's very possible that we'll have a couple of more sessions from the SQL Server Tiger team coming up in August and September. Again, our sessions will be recorded, and this is where you can get to our meeting archive, or you can also look at them on our YouTube channel. If you, again, want to hit the camera icon at the top of your screen, I'll hold this here for a second so you can click on that. And PASS is supported by volunteers, basically. Most everything's free. The Summit's not free, and people will charge you. Well, I forgot to mention SQL Saturdays. That's sort of like a mini summit close to you all the time, and all you have to do is pay for lunch normally. So it needs volunteers. You can go to these links and find out how you can volunteer. You don't have to start out hosting a virtual chapter yourself. You can start out small, helping other people, helping the local chapter, helping the local SQL Saturday people. There's all sorts of ways to help. Okay, that's all of our housework I can think of. My name is Steve Cantrell, and I'm the chapter co-leader. you can send us questions if you want to by going to our About Us tab. If not, I'm going to move on to Ajay. Ajay Jagannath is with the Microsoft SQL Server Tiger team. They're sort of, that's their job, to go out there and show all of the new features to everybody. It's like a dream job to be able to do that if you're good at doing presentations. Anyway, today Ajay is going to be showcasing several improvements to the database engine for SQL Server. He's going to talk a lot about 2016, but is also going to show enhancements for 2012 and 2014 also. So you're going to get a mixture of everything as well as a lot of 2016 stuff. Let's see. Okay, Ajay, I'm not going to go into it very much. I'll let you explain it. Let me change it over to you, and I'll make you the presenter.
Okay, let me know when you can see my slide.
I've got it.
Okay, let's get started. Thanks for the invitation and opportunity to be present in this chapter. It's always a pleasure to showcase some of the improvements our team does and some value that you and your customers can get out of it. A quick introduction, my name is Ajay Jagannathan. I'm a program manager in the Microsoft SQL Server product team. We are also known as the Tiger team, and we work very closely with customers who are using existing platforms. That's why you also see us doing a lot of work in service packs and cumulative updates. Everything comes out of our team. You can follow me on my Twitter handle or our team blog and team Twitter handle, where you will see a lot of links to articles and updates and features as we release. And today's topic is specifically focused on the database engine. I've spent the last 17 years of my career at Microsoft in SQL Server database engine primarily, and one of the primary goals for our team is to learn from customers and incorporate that feedback into the product. So today we'll talk about some of these enhancements that we have made in both SQL Server 2016 as well as SQL Server 2014 Service Pack 2. The main takeaways for you folks is one of the biggest learnings for us is as the product grows and matures and it's used in more and more tier 1 mission critical environments on bigger and better hardware, one of the things we want you to be happy with is out-of-box performance. So the SQL Server performance and scale should just work without having to remember hundreds of ways to tune it. I'll also show you some new diagnostics we have added. This is some of the common tasks that you do as DBAs, such as backup, restore, etc., and how you can use that to troubleshoot some common problems. And then finally, basically demonstrate some of the scale features and see how SQL Server will automatically use this going forward, and some of the best practices you can also follow to leverage some of these features. So as most of you know, SQL Server is a tier 1 RDBMS, and a lot of customers are using, like banks, healthcare, insurance, etc. And the product has become complex from the days of the initial versions, where you have a lot more knobs in the form of trace flags or configuration options that you need to remember to tune. And for example, today on any high-end OLTP system, we see that at least 5 or 6 trace flags need to be turned on by default, as well as configuring databases like tempdb and also your SP configure settings for memory and such. The second challenge we hear from customers is the database maintenance piece, whether you're doing database integrity checks, which is DBCC, whether you're doing index rebuilds, partition changes, schema changes, there is some downtime that you have to take for planning some of these. So this point is just a feedback at this point. I do have some things to share. We may not get to it in today's presentation, but we will look forward to presenting it in the future time if that happens. And the last thing is, how can we make it easier for people when there are issues to troubleshoot it quickly, mitigate them with the data that we provide. So some of the data that we send are in different formats. Some of them go to the error log. It's unstructured. You have to parse through the logs through tons of messages. Sometimes it goes through X events, which are not sometimes easy to read. So the goal here is to take all this feedback and make it easier for database administrators to manage their SQL Server instances. So in today's session, obviously we cannot cover every single improvement or enhancements. I'm going to be focusing on the topics listed on this slide. So on the performance and scale side, I will talk about some of the changes we have made to tempdb and user databases, some of the changes we have made to memory allocation and CPU configuration for high-end systems, and we will also look at, from a diagnostics perspective, what enhancements are available for some common tasks such as backup, restore, or database recovery. So let's look at performance and scale features which are going to be turned on by default. So before I get to that, one of the things you must know is with SQL Server 2016 and upcoming Windows Server 2016, we will be supporting 12 terabytes of memory, which is unheard of. So you can think of pretty much most of your databases being memory residents. And at the same time, Windows Server 2016 will support unimaginable number of physical cores on sockets. As an example, if you look at the bottom right, HP Superdome X, which is the biggest hardware that is currently available, has 16 physical processors with 15 cores per socket, which is 240 cores. And if you enable hyperthreading, that's like 480 logical processors with 12 terabytes of memory. You can just imagine the scale of the product and the memory footprint, as well as from a DBA point of view, the challenges around troubleshooting and diagnostics and stuff like that. So our goal is to make it easier for you folks. And another point I want to highlight is at the bottom of every slide, you will have a marker like this, which has either a green circle with the label SQL Server 2016 or a blue circle with a label SQL Server 2014 SP2. This is just to simplify me having to repeat and a good reference for you after the fact. So if you see only this green label, that means the content in that slide applies only to 2016. If you see green and blue, it applies to both versions. And in some slides, I have specific bullets which may apply only to one or the other or both. So I'll show you an example when I get there. So I just spoke about what the new hardware and new versions of SQL Server will support. Now let's look at some of the improvements we are doing to the product itself to scale on such hardware. The first and most common feedback we get is around tempdb. As most of you know, tempdb is a scratch pad for SQL Server. Pretty much it's like a junkyard, if you will. People throw everything there, and tempdb has to handle, for the whole instance, there's only one tempdb. So if we are hosting like 1,000 databases, all of them share tempdb. Treat tempdb as a central resource for the instance, just like you will for CPU or memory or disk, which means if you have one bad query or one database application which is using tempdb or hogging all the tempdb, it can affect other applications or resources on that system. Some of the common problems we see are one, which is allocation latch contention. So allocation is when you're using tempdb, when for example, if you're creating temp tables, table variables, or internally if SQL Server is query plan generates sorts or hashes or exchange spills, all this work is done in tempdb. So anytime any work need to be done in tempdb, we have to go and allocate pages in tempdb for that session to use. As part of that allocation, SQL Server has to go and acquire some internal logs which are called latches on system pages, which tracks which session is using, which object is using those temp certain number of temp pages. It's just like in user database. So the common contention points we see are on 3 system pages, namely PFS, GAM, and SGAM, which track the free space available. PFS stands for page free space, GAM stands for global allocation map, and SGAM stands for shared global allocation map. So it basically, the 3 of them together track what pages are free. So if a new request comes, it can tell that session, you can go and take these pages, and then it has to go and update these system pages that this is going to be marked as used by a session. So now imagine like thousands of stored procedures creating temp tables, all trying to create temp objects, and all of them will have to go to PFS, GAM, and SGAM and go and lock it, look for free space, mark it as used, and then release the lock. So next one. So on a very heavily concurrent tempdb workload, we see a lot of contention on tempdb. The common solutions you have today are 2 trace flags, 1117 and 1118, which will allow you to create multiple files, grow them in parallel, and also do round-robin allocations and mixed allocations to reduce some of the contention, but not fully eliminate. We have well-published KB articles and blogs by Microsoft and all the external resources providing some guidance around this. The second problem we see is what we call metadata latch contention. Again, in a very heavy tempdb workload, what you will see is, let's say you are creating a temp table in a stored procedure, and this stored procedure is currently executed by 5,000 users in parallel. So anytime you create a table, SQL Server has to go and make entry into system tables like sysobjects or sysindexes, for example. So again, to do that entry into those system tables, SQL Server has to acquire internal latches, and on a very busy system, you will see that threads are waiting on latch EX wait type. So this can also cause blocking and slow down in your query performance. Unfortunately, the only ways to get around this is reduce the number of temp tables that you're creating, or do some other workarounds like inline derived tables and such to reduce the contention. So this is the 2 main common pain points that we see with tempdb with customers using SQL Server today. So what are we doing to change that? Before I do that, we do have a KB article. You might want to take a screenshot of this, which we have a lot of best practice recommendations, not just for tempdb, but in general for SQL Server today, on what updates to apply, what trace flags to turn on, etc. So it's a very good bookmark to have as a reference. So what is changing? So in 2016, we have removed the need for 1117 and 1118. These 2 trace flags were introduced in SQL Server 2000 days, so it's pretty much on by default in most customer systems, and we feel that there is no longer a need for this code to be under the trace flag. So whatever benefit these trace flags provide will now be on by default. What this means to you is, if you're upgrading to a new version of SQL Server or installing a new version of SQL Server, you don't need to turn this on. One of the common things we see is people forget to turn it on, and they suddenly hit a production outage, and then they realize that they forgot to turn it on. So we can take out one of these worry factors from you on having been paged or called at night hours when something is down. So the first 2 trace flags, removing that will basically improve or reduce your allocation contention, which I spoke about. The second thing we have changed is the metadata latch. When I told you that every time we make an entry into sysobjects or sysindexes, whenever you create a temp table, we have to take a lock. So we have changed the way we do that, acquiring the lock and releasing the lock. So we are doing a lot more optimistic thing for temp tables. Now you will see much reduced contention by changing just those algorithms. You don't need to worry about what the algorithm itself is and such, but it's a little more optimistic in that if there are multiple shared queries coming in, then you will not have to worry about contention at that point. The third thing we are changing is, especially for people who are new to SQL Server or junior DBAs, we want to help them set up tempdb correctly when they're installing SQL Server itself. To help with that, we have changed the default values of the tempdb file sizes and the number of files. as well as the growth settings, which is in the setup dialog, as well as command line setup, which I will show you shortly. The next thing we have done is same thing for user databases. So in the past, the trace flag 1117 and 1118, though it was intended for tempdb, but if you turn it on at the instance level as a SQL Server startup parameter, it impacted all databases. So what we have done is we have removed, since we removed the trace flags for tempdb and made it on by default for temp databases. What about user databases? For user databases, we did not turn on 1117, 1118 behavior by default. Instead, we are providing you alter database keywords which you can turn on or off if needed for user databases. Typically, in most user databases, you will not see the same problems. So, for example, allocation goes to a different page in the index, so it's not the same contention points that you'll see as in tempdb. And if you have partitioning, you'll be going through different partitions, so you we are adding new extensions for alter database to control the database for user databases itself. So for 1118, if you need uniform extent allocation, you can turn on alter database set mixed page allocation on. The default value is off. So what this means is if you turn it on, SQL Server, you will use only mixed extents, which means you could be contention on SGAM pages. If you do uniform extents, you can remove contention on SGAM pages. So the default is off, so you will not see the contention. And if for some reason you want mixed extents, which will basically be a small space saving, because if there are many small tables in your environment, you can use mixed extents. Otherwise, you don't need to use mixed extent. The next one is trace flag 1117, which will trigger auto grow of all files if enabled. So for tempdb, it makes sense because you want all the files to be of the same size, so the allocation is equally shared across files. But for user databases, we got feedback that if you're inserting data into only one partition, if it's growing, then it has an undesirable effect of impacting all the files, even your read-only partitions. So people did not want that behavior. So the default behavior is we'll only grow one file. If you want all files to grow, you need to do alter database auto grow all files. That way you will see the same effect as in the previous versions with trace flag 1117. Again, these two slides are new to only 2016 because it changes the default behavior. We didn't want to impact existing versions if people have already set it up in a certain way. So this slide, again a good slide to capture a picture of, is a summary of what I just spoke about in the previous slide. So for tempdb, you don't need the trace flags anymore. You will get the benefit of the trace flags automatically. For user databases, trace flag 1117 behavior is off by default. If you need that behavior, you need to use autogrow all files. For 1118, it's on by default, but you can turn it off by using set mixed page allocation on. And these two settings are really not very useful for system databases like master model and MSDB. So you don't need to worry about turning on or off this for system databases. So the next thing I mentioned to you was setup changes. A couple of key changes we have made. One, in the SQL Server 2016 setup, here's a screenshot of the dialog. When you get to the server configuration window of the wizard, you will see a checkbox now which says grant volume maintenance task privileges. What this does is it enables a Windows privilege called instant file initialization. What that does is if you are creating very large data files, let's say a terabyte size data files, or if you have a large auto grow like 1 gig, 2 gig, SQL Server will not have to zero every single page in that file when it's creating the large file or auto growing a large file, because that can impact performance of your queries. For example, if you're doing a bulk insert and it triggers an auto grow and your auto grow is, let's say, 10 gig, SQL Server will, without this setting, have to go and zero out every single page and while it's doing, the bulk insert will be paused, so it'll severely affect query performance. So as a best practice, we recommend turning this setting on for the SQL Server service account. So if this is on, Windows will create the file immediately and you don't have to zero it out. It only writes the pages as it uses the pages, so it's much faster. So that's one change that we have made. The second change we have made in setup is we have added a new page for tempdb itself in the database engine configuration page. There are a lot of good stuff here which I'll talk through. One, we will detect the number of cores, logical cores the system is using, and recommend the number of files automatically. You can of course change it. So we stop at 8 because we have found that 8 is a sweet spot to start with, but your workload may require more files or less files depending on how much you use tempdb. So you can increase or lower it, but the best practice is to match the number of cores that you have. The initial size and auto grow, we changed it from % based growth to fixed size. We picked 64 MB because that is one PFS page interval, so that lines up very well. Every time you auto grow, we create one PFS range of pages. And we also allow you to specify data directories, and we will round robin the creation of tempdb files across these data directories. For example, in this screen you have 8 files, and if you specified only one data directory, all the 8 files will be created in that data directory. If you specified 4 data directories, then we will distribute the 8 files across those 4, so 2 per volume. And if you had, let's say, 8 volumes, then we will create 1 per volume. That way, if you want to set up a mission critical environment, you can manually, in the past you'd have to manually install SQL and then go run some scripts to move the file, stop SQL Server, restart it. So all that will be taken away and simplified with the setup itself. As far as the file names itself, the first file will be called, the primary file is tempdb.mdf, and for each secondary file that we create, depending on the number of files you pick, we will add this suffix ms_file number. So these names cannot be changed, and this way you can recognize that these are files created by tempdb. For log file, of course, only one log is sufficient because log is sequential, unlike parallel I/O that can happen for data files. Again, we specify an initial size and auto grow. This is to keep the number of virtual log files controllable. One of the things we see is if virtual log files that SQL creates internally are too big, then it can have performance issues, and also issues with garbage cleanup and trigger auto grow. So now moving on, continuing with the theme of large system support. So in this example, you see that I have both the blue and the green markers. So the first bullet applies to both versions. SQL 2014 SP2 will be releasing shortly within the next couple of months, so you will be made aware of this. So in the earlier slide, I showed the specs of the new hardware where you have more than, you have 16 sockets and 15 cores per socket. So what we have seen is once you have machines with more than 8 cores per physical socket, SQL Server can hit some scalability bottlenecks within the engine. So SQL Server creates a lot of data structures in memory to manage your engine. For example, there are data structures to manage your buffer pool, to various memory clerks, to memory allocations, to accessing different structures related to lock manager and stuff. So when multiple threads are accessing different parts of the database, these structures have to be logged and updated so that the concurrency is honored and also the data is correct. What we have seen is if you have more and more cores per socket, it can cause a long blocking on these internal logs. Think of it like if you're going to a grocery store or let's say Walmart, and you're going to the during the busiest hour of the day, and if only one checkout counter is open, then everybody who wants to check out is waiting, right? Only one person can check out at a time. So think of it like that. So if there's only one memory object, if you have multiple threads, all of them are waiting so each one can go and access it. Whereas if the manager of the store realizes that, hey, the queue is building up, I need to open more checkout counters so more people can run in parallel or check out in parallel, then you can check out faster and reduce the blocking and increase concurrency. Same concept here. When I do a demo, it'll be clear. So what AutoSoft NUMA does is it detects if you have more than 8 cores per socket. So each socket could be a NUMA node. So if you have more than 8 cores per socket, we will internally break it down into smaller soft nodes. So let's say you had 2-node machine with 24 cores each, so 48 cores. We will break it down into 4 nodes, each with 8 cores. We'll break it to 6 nodes, each with 8 cores. So that you will have a lot more nodes and fewer cores per socket. So I'll give you an example and it'll make it sense. And this is on by default in 2016. In 2014 SP2, you'll have to turn on trace flag 8079. The reason we put it on a trace flag is we don't want you to magically change the behavior of the system when you apply service pack. So we want you to cautiously enable it and see the impact, and if you like it, leave it on, and then when you upgrade to 2016, you will not see any difference. The second thing is we have added a note to the error log if we detect AutoSoft NUMA, which I'll show you shortly. So that way you will know that this is in effect. And finally, in 2016, this has a green, doesn't have a blue circle, so this applies only to 2016. There's a new column in the DMV where you can check what the state of NUMA is if you're using any scripts. So the second problem we see is very common because anytime SQL Server runs any query, the first thing it does is it needs memory. So we see a lot of contention on memory on really high-end systems, and I'll explain that through a visual, and then we'll do a quick demo. So think of CMEM thread if you at a high level like a checkout counter in the grocery store example, so it makes it easier for you to understand. And initially, let's say there's only
Ajay. Hello? Hello? Ajay.
So this is basically serialized, so only one at a time can do this.
Ajay, can you hear me?
Can you folks hear me?
We lost probably about 15 seconds, maybe 20. It sounds good now, but for some reason we lost you for about 15 or 20 seconds. You back? Hello? Okay, we are experiencing a few technical difficulties here. Ajay, can anybody hear me? Okay, so people can hear me. They can't hear Ajay. Ajay.
Can you hear me?
I can hear you now.
Okay, I think there was a temporary glitch.
Okay. So back up about 2 minutes.
Which slide?
You're on. It's on the current slide, but start back just a little bit. Yeah, right there. That's good.
Okay, I'll start here.
Yeah, with the grocery store.
Okay, so yeah, CMEM thread is an internal object that SQL Server uses to maintain some memory data structures anytime any query wants to allocate memory. So pretty much everything that comes to SQL Server first will have to go through this, since anything you need to run first needs to acquire memory. So it's protected. Data structure is protected by what we call CMEM thread. It's a mutex in the programming language, and only one thread can access it at a time, as seen in this example. Let's say you have 4 threads running, and the first one acquires it, which is indicated by the green arrow, and the other 3 have to wait. So this is like in a grocery store. If only one checkout counter is open, everybody lines up one at a time and checks out. So what people typically assume is, hey, SQL Server is hitting scale limits, we need to put more hardware at it, so they upgrade to a bigger hardware with more cores or sockets. But what really happens is it only makes it worse, because internally you still only have one copy of this checkout counter. So which means you're going to increase the contention, meaning more threads will wait and one at a time going out. So this basically results in severe performance degradation, and you will see a lot of waits on this mutex if you look at your wait stats. So so the common solutions for this is, in the past we have trace flag 8048 for CMEM thread, but that only created additional copies of this, as there are a number of nodes which may not be sufficient. I will explain what that means in the next slide. And there is similarly, just like CMEM thread, there's another contention in a data structure called log pool. This is used by the transaction log activity, especially in always on, where the primary replica is sending log records to the secondary. It uses the log pool as a cache and directly sends it from there instead of reading from the disk all the transaction logs. So this is a performance improvement, but that also, there is only one copy for the whole instance. Imagine you have thousands of databases, everybody is trying to access one single copy, and you can imagine the performance bottleneck that will happen. So these two trace flags have been removed in the next version and the SP2 also. So what is the new experience? So in this example, let's say you have two node machine with 24 cores. So you basically have 12 cores per node. And we start off with one copy of that object, and you see that only one thread has acquired it, all the others are waiting. But SQL Server will dynamically detect, hey, there's contention happening, one copy is not sufficient. We will next partition it by node. What that means is we will detect how many nodes are there on the system, so in this case 2. So we'll create 2 copies of that memory object. Think of it like the manager of the grocery store realizes, hey, the line is building up, I need to open one more checkout counter. So now we have checkout counter, so you can split the line by 2. So the wait time is reduced significantly. But still, in some workloads, this may not be enough. As you can see that even with 2 nodes and 2 copies, only 2 threads can access one of each at the same time, but there can still be contention. And SQL Server will again detect this situation, and then the last thing is partition by cores, which means you'll create as many copies as there's a number of cores. So in this example, we have 24 cores. We'll create 24 memory objects analogous to 24 checkout counters, and now you can see that it's a lot more concurrent and it scales automatically. So we have seen significant performance improvement just by doing this improvement by default. All the detection logic is automatic. I'll do a quick demo and show you some of the benefits. And again, I mentioned that we detect the contention on CMEM thread. The way we do it is we will see how many threads are waiting on the CMEM thread object over the last 100,000 allocations. So if there's at least one wait during each time a new thread allocates, it checks if there are any pending waits, and it increments a counter, and we average it over last 100,000 allocations. And if the average is more than 1, we detect that memory object as hot, and we will promote it to node partitioning. If it is still hot, we'll promote it to CPU core partitioning. And you can see from a diagnostics perspective, you can look at the DMOS wait stats, DMV. You will see the number of waiting tasks on CMEM thread will keep going up. And we have also added new columns to memory objects DMV, where you can see the contention factor, if it is partition, etc. We have also added an extended event which will get fired every time we promote. So for DBA, these 3 are good tools to know if you're hitting these hotspots. And if you have to, even if after this improvement, if you're still seeing problems, this is the data that Microsoft will request for you to send it to us. So it's good to know about this. So let me do a quick demo of both of these, and we can move on to the next topic. So the first thing I'll show you is AutoSoft NUMA. So I'll show you through the error log. So you can see on my screen that I have an error log open from one of the large machines. So you can see that this machine has 2 sockets with 12 cores per socket and 24 logical processors. Hyper-threading is enabled, so you have 48 total logical processors. So since this has more than 8 cores per socket, you can hit some of the contentions we just discussed. So since AutoSoft NUMA will be detected by this instance, we will enable AutoSoft NUMA and you will see a message be like this. And you can see that though we started with 2 nodes, because AutoSoft NUMA is enabled, SQL Server will create 4 nodes. So this is how you can detect if AutoSoft NUMA is enabled. For 2014, you will have to enable the trace flag 8079. For SQL Server 2016, it's on by default. You can turn it off using alter server configuration, or you can use SP configure to turn it off. So the next demo I want to show you is the memory object partitioning. So this one I will try to do the demo. It's a very high-end hardware with specific contention we have to reproduce. If it's not, I have a video which we can play and look at. So what I'm going to do is first go to my management studio. So we can look at the number of nodes and number of schedulers created by the node. So you can see that there are 2 nodes. Oops, the zoom it is not working on this. Okay, 2 nodes, and then we created, since we have 48 cores, we created 0 through 47, 48 schedulers. I'm going to turn off the dynamic partitioning so that we can show the problem first, and we can see how the solution addresses the problem. So for doing repeated memory allocations, I have created an extended proc which just repeatedly calls xpalloc, and which goes through the memory allocation routine repeatedly, so we can see all these going through the cmemthread object. And all of these allocations will be going through the memobj xp memory object pointer within SQL Server. So you can see right now that it is not partitioned. One means it's partition capable, but it's not yet been partitioned. I have no workload running, so my contention is 0 and no tasks waiting. So let me go ahead and clear all the stats so we can start with a good baseline, and we can see that there are no waits on cmemthread. So I also mentioned the extended event we have added, which will promote, which will fire every time we promote from 1 copy to node, which is 2 copies, and then to cores, which is 48 copies. So let me go ahead and I have already created the session, I think, so let me try this. Yes, it's created. Let's go ahead and start the session. And before I run my stress, what thing we can do is I have 2 performance counters. One is batch requests per second, which will monitor the throughput of the system for SQL Server, and then waits per second to see if there are any bottlenecks. So let's go ahead and start performance monitor. And next, what I'm going to do is start a workload. I have a script which will basically call that extended proc. But before I do that, let me make sure I have disabled. Okay, so this created 24 threads. So this 24 different connections are hitting the server and running CPU. Now let's go and look at the memory object and see if there's any workloads. And you can see the contention, it's already hot, and you can see it's up to 5 million tasks already waiting on this. And I can also show you the waits on cmemthread itself. It's up to 261,000. It's going up 298, 315, so it's just getting worse. So all these threads are waiting, and you can see that the CPU is also starting to hit heavily on some of these cores, several of these cores. So SQL Server is pretty busy. It's actually doing no work because all of the threads are contending. So I'm going to go ahead and enable the dynamic promotion by turning off the trace flag. So I did that. Let's clear the stats. And now let's look at how many threads are waiting. And you can see that it significantly dropped from almost 500,000 to 1 million down to 444. which is okay because the wait time is also very small. From more than 1 or 2 seconds, it came down to a very small number. And if you also look at the mem object itself, you can see that it's partitioned by node now. Previously it was 1. 1 means it's partitioned by, it's not partitioned yet. 2 is partitioned by node. So we created 2 copies of CMEM thread. And if its contention more than 1, it'll partition by CPU. So we'll create 48 copies. So we haven't hit that spot yet. So it's stopping at node level for now. So we'll dynamically create copies only if needed, because there is an overhead for creating all the 48 copies upfront, because you have to maintain the lists and make sure all the lists are synchronized, because different threads could be using different memory objects. So we only create it as required. I'm going to go ahead and stop the X-event session, and let's look at the performance log here. Let me go ahead and stop that. So this really shows the problem is, so if you look at wait stats, when we started, when the workload was heavily contending and it was not promoting, you can see that it was averaging around 16,000 with a peak at 51,000 waits per second. And you can see the batch requests per second, which is the green, was very low. And as soon as we promoted, which is the switching point here, the waits pretty much dropped to 0, and the batch requests went up significantly higher, and it went up 3-fold to 8,000 plus. So this dynamically improves the performance, and hopefully this will address a lot of your common performance bottlenecks as you move to modern hardware. And final thing I wanted to show you is the X-event itself. So I actually have it open in this window here. So you can see this is an older snapshot. The first time it detected a hot partition 3 was hot, and contention factor was more than 1, so it partitioned it by node. And then the contention was still hot, so it was above 1, so it decided partition by node is not enough, so it partitioned it by CPU. And you can see which scheduler the contention was detected in, which is 36. So with this data, you can quickly diagnose this problem, and if you need to engage Microsoft, this will be very useful to see. Let me go back here and stop my workload. Okay, so going back to the presentation. So the next topics I want to talk to you about is improvements in diagnostics and management. So the first one we'll talk about is backup and restore. As DBAs, most of you have this common challenge is backup and restore is pretty much a black box as it comes to you. These are long-running tasks. A common problem is you don't know when it'll finish once you started. There's not enough insight. So you have to turn on, usually when you call Microsoft, they ask you to turn on a bunch of trace flags, and all the information is dumped into the error log. It's very unstructured and hard to interpret, and a lot of cryptic information which only you will understand if you look at SQL Server source code. So what we have done is a couple of things. One, we have cleaned up all the trace flags and consolidated into a single trace flag if needed. We also have formatted the messages. Every backup will have the word backup and the database name prefix. Every restore will have a restore database name prefix. And another thing we did was some errors, if you run it as a script or a SQL agent job or from Management Studio, they are not persisted in the error log. So for historical reference, it may be lost. So now we persist all error messages to the log so we can go back and look at it. In addition, we have also added a new extended event called backup restore progress trace, which can be dynamically turned on or off real time during a backup or restore. There is no performance impact, and you can immediately get insight into which stage of the process it is in. The next diagnostic investment we have made is in database recovery. So this is another common problem we see with customers is the SQL Server instance restarted, or they restored a backup and then database is stuck in recovery. It's not it's taking several hours to come online. Some of you may have seen messages that similar to this, recovery of database is X% complete and approximately some 20 hours remaining, stuff like that. So, but there's not much visibility into what SQL Server is actually doing. Sometimes even Microsoft will request you to collect memory dumps and such. So what we have done is we have created many different X events which will give you a lot more insights into different phases of recovery itself. There are three key phases that happen, which is analysis, where we go and analyze the entire transaction log and build what transactions need to be redone and undone, and then we do the actual redo and then do the undo. So all this information will now be displayed to you with complete details, and this can also be turned on dynamically anytime during recovery, and SQL Server will start showing you information from that point on forward. So here's a sample screenshot of a large database recovering. The first event progress report will give you the key phases, which is analysis, redo, and undo, and how much time is remaining, etc. And also for specific steps, the step itself is more internal. It's more reference for Microsoft in case they need to troubleshoot this deeper. So let me show you a quick demo of both of these X events, and then I think we'll be towards the end of this session. So here I have an extended event session called backup trace. I'm going to collect the backup restore progress trace, and this will start emitting information anytime you do a backup or a restore. So I think I already have it created, so I can just let's see what happens if we start it. Okay. Yeah, it looks like that instance is down. Let's try it on a different instance. Okay, I'm restarting the instance and we can look at it from here. Okay. So I have a backup restore session already created. Let's go ahead and start it. And then all you have to do is a backup database, and then it'll start firing the events. So I have already collected, so in the interest of time, I have already collected the event, so you just have to do a backup. I don't have this database on this instance, and then you can do a restore. For both purposes, you can see the events. So I'll go and show you the trace, how it looks. So for backup, let's go back up here. You can see it already spit out so much information. So I have bookmarked a couple of key steps. Let me hide this so we can maximize this. Okay. So the first one is, which is important, is we display all the options the backup process used. So you know that the backup command can be given different options like checksum, corruption, encryption, buffer size, etc. So we show you all the options that were used, so it's good for troubleshooting. The next thing we show is various stages, but what is important is how long checkpoint took, because if your tail of your log is very big, checkpoint could take a long time, so this could affect your backup performance. So we show that information. The next useful information is what is our estimated size that we need to back up, so which is also shown here. For each, we actually show that for each file that we detect, each MDF and LDF file. And then we start emitting information at 5% interval as we start writing the files to disk. So this will go in 5% increments. You can see how many bytes have been written and what is the total bytes remaining. I'm going to skip all this. So all the stuff here you see is going through the virtual log, transaction log, and going through file IDs. 2 is transaction log, and then there are 700 and something VLFs. So it's going and reading all the transaction log, virtual log files to back that up. I'm going to skip to the more important stuff here. Okay, so once the log files are written, the next you can see the backup completion message itself, which is ending of the metadata. And the final thing is to log into MSDB. So sometimes if that fails or if that is slow, you will know that the backup itself finished, but writing to MSDB took longer and such. And same thing during restore. So the next set of events I have in the same screen is restore. One thing you can filter on is you can, since this is extended event session, if you want to troubleshoot only for a specific backup, for a specific database, you can modify your session to say, hey, just filter it in for database name or database ID 10, for example. And if you want to troubleshoot only backup, you can do operation type equals backup or operation type equals restore. So that way you're not bloating your extended event log. And for restore, we will see something similar where you will see all the options like you see here. Then you will see for restore the progress of 5% also applies. So you will see every 5% increment you will see progress in the information. One of the most useful information during restore is also transaction log because we have to replay it. So you will see the progress of reading through every VLF. And then just like backup case, at the end we will write to the history tables, which is also recorded here. So this is the single event you need for both backup and restore troubleshooting, and it will give you a lot of rich information. The next one I had was a recovery piece. So recovery happens in a couple of different scenarios. When you restore a backup, it has to go and do a recovery of the active portion of the log since the last checkpoint. So it will basically redo all the committed transactions and undo all the uncommitted transactions. A couple of other scenarios where recovery happens is if you take the database offline and then online. So again, it has to recover everything from the last checkpoint. And the last part is crash recovery. So if you stop the SQL Server instance and restarted it, or the machine rebooted unexpectedly, SQL Server goes through crash recovery for the database and the recovery happens there. So depending on when the last checkpoint was, you may have a lot of transactions to recover or very little transactions to recover. So this is really useful in long recovery cases. So in this X event, I'm showing you the different phases of recovery. So during analysis phase, it shows you how many bytes it has to analyze, how many virtual log files are there to be read, and some LSN information and additional debugging stuff, which is useful. It shows you how much time is remaining. It repeatedly gives you analysis. For each phase, it gives you the stats, how many blocks were analyzed, how much time it took. And when the redo phase starts, it gives you how many bytes it has to redo, and there's no transactions to be undone, so it's a 0. And then at the very end, when the entire operation finishes, you will see overall stats, which is useful. So you can see that it took 6 seconds for analysis, so many seconds for undo and redo, etc. And the overall time it took for recovery itself, which is 19 seconds. So that's the end of the demo for backup, restore, and recovery diagnostics.
Jay,
yes.
There's a question. I'm not sure if it exactly relates to this. It does a little bit. Just like the new syntax for table, Server 2016, if exists drop table, isn't there a change made for event session?
No. So the question is if you have a create or alter syntax, is that what the question is?
I think that's what it is.
Drop if exists, right? No, drop if exists is not there for external events yet.
Okay. Maybe that's a Connect question that somebody needs to set up.
Yeah, that's a good feedback to share and connect if that's something useful, yeah.
Okay, the other question when you were on that screen, What's that grouping and aggregation in the toolbar on SSMS? Is it new? Is it a new feature for 2016 or an added component?
So this is a great question. This has always been there with X-Events, and that's actually a good topic probably for a future presentation on the capabilities of X-Events. So starting 2012, we deprecated profiler trace. So all the investments for the database engine has been in external events. So for people who are used to using Profiler, which is a standalone tool for older versions, and it still works, for external events, everything is hosted in Management Studio, all the visualization, and you can actually do grouping of various events and such. For example, let's take here, and I want to group on the event name itself. You can see that I have 6 events of database recovery times, 4 for progress report, and 5 for recovery trace. And then you can do aggregation. You can, for example, you want to do like here. There's not a good column to aggregate. If you're doing traces of queries, you could do aggregate on duration or CPU to find out what are your most expensive queries and such.
Okay, he had a follow-on, the guy about the if exist. He was asking if that might be in the next service pack on 2016.
For external events?
Yes, the dropped, the if exist drop.
I don't know. We'll have to follow up, but I definitely recommend filing a connect feedback on this so we can take a look at it.
Okay. And I think the answer to this is no. Can you install SQL Server 2016 on a Windows 7 machine? Doesn't it require a higher version?
Again, I don't know off the top of my head. The Books Online page has a reference to hardware and software requirements. If you search for that in 2016, it'll tell you all the minimum amount of hardware needed, like memory, CPU, disk, etc., as well as versions of the OS that is supported.
Okay, that's it. Go on.
Yeah. So just to wrap up, just in time, hopefully you got a good understanding of some of the performance improvements to make it work better out of the box for you without having to remember a bunch of configuration and scale on modern hardware. You also had a chance to look at some of the diagnostics such for X-Events that we have added for both the memory allocation as well as backup restore and stuff. There are tons of more features. We hopefully will get a chance to present it to you in the future session. And feel free to play with it. And take a screenshot of this page. All the demos that you saw today and the recording will be on YouTube, I believe, in the past chapter. Demos, we'll post it on GitHub. Twitter, follow us on Twitter. It's a good place to learn about what's coming in updates and service packs and features, as well as our blogs. And we also have a Twitter chat with hashtag AskSQLTiger coming up on June 27th, next week. The details are in that blog post. You can basically log in during a specific time and use that hashtag to ask any questions to our engineering team.
Okay. Well, I appreciate it. We all like to know the new features that are coming out and things that are being added in service packs so we can implement them. I think consolidating, getting rid of a lot of the trace flags that everybody did anyway only makes sense. Anyway, I will probably be able to get you back in August. If everybody has a picture of that screen, I'm going to move back to my screen real quickly. Well, I'll just leave that up. People may need to get that. Anyway, just wanted to remind everybody about our session coming up in July, which is with Kendra Little on the 3 things that all DBAs, all junior DBAs need to know. And just because if you're not, even if you're not a junior DBA, you might want to show up anyway, because I have a feeling that these are skills that soft skills or things that everybody could use. So anyway, I appreciate it, and thank you, Jay. And if you are coming back, we hope we can do that. Hope we can work that out. And thank you. Bye.
Thank you. Thanks for the opportunity and looking forward for more sessions. Thank you.
Jay, there were a couple, let's see. There were some questions that didn't necessarily relate to the engine. I'll send them on to you anyway.
Okay.
But I didn't want to ask those. There was one about SSMS and one about column store and in-memory OLTP features. But I'll go ahead and send you the questions that are there, and you can look over them. And if you want to do something on the blog, or if they want to get in touch with you on the June 27th Twitter chat, that'd be good.
Yeah, so definitely send my way and we can answer those and put it on our blog along with this session, or do it on Twitter too. That either way works.
After I get everything up and going, I'll send you the links so
Yep.
you can put it on your blog, and I look forward to working with you again in August. Who's
All
doing
right.
the July? I forgot to mention the July. I mentioned it
Is it
earlier.
Pedro? Is it Pedro?
I'm not sure. It might be was Amit going to be doing that one? The July 7th.
It might be either Amit or Pedro.
I think it was Amit on July the 19th. But anyway, I'll be sending out, when I send this out, everybody will know. But anyway, I think we
Okay.
probably got about, I haven't listed it out, we've probably got 240 or so, maybe 250, possibly. So it was a pretty good session, and I really enjoyed it. And I like the fact that you didn't try to cram too much into it, because sometimes I'd rather give a second session sometime to spread it out. So if you want to go ahead and send me the abstract of what you're going to add in and do on the second one, we'll talk about it, and we can maybe go ahead and get it scheduled for August.
Yep. Sounds good.
Okay.
And forward to it. Thank you.